Okay, I think everybody should be on. Great. Ready to start? Lucas, you still there?
Yeah.
Okay, great. Well, welcome to the webinar on the future of Docker and Linux containers. My name is Jim Palmieri. I'm the CEO of Agitair Technologies. We're a consulting firm that specializes in the area of cloud, big data, do DR as a service, applications development. We're also a master partner for CenturyLink. We also organize the local technology community Cloud Talk, which some of you may have registered through. So we're excited to be hosting this event about Dockers. And we got a few housekeeping before we get started. So we'll have time at the end of the presentation for questions. There's a questions pane on the right side of your GoToWebinar toolbar, so you could ask questions during the event, and then hopefully we'll have time at the end to answer those questions. We're also recording the session, and we'll post it on our site afterwards. Okay. So Dockers is getting a lot of attention in the DevOps community, and we're excited to have Lucas Carlson, the Chief Innovation Officer at CenturyLink, here as our presenter. So Lucas, you're a well-known author. You wrote Ruby's Cookbook, the Programming for PaaS. You're a thought leader in the DevOps community, former CIO of AppFog. And you guys are doing some really cool stuff with the CenturyLink Labs. Can you take a moment and provide a self-introduction, talk a little bit about your background, some of the innovative things you're driving at CenturyLink, and then what I'll do is I'll turn the presentation over to you and you can drive it.
Yeah, in fact, I've got some slides in the deck so I can talk people through it and they can see some visuals.
Okay, so I just gave you control.
Okay. Let me share my screen here. I think you need to share the.
Yep. You should have it.
Go.
Okay,
yep.
Just took a minute.
Okay, can you see my my screen?
You can.
Perfect. So before I tell you a little bit about myself, I'd like to tell you the three things I'm hoping you will remember at the end of this conversation. So, you know, I've been part of a lot of, I've seen a lot of presentations, and a lot of the time I hear a lot of information, and I try to keep track of it all, but at the end of the day, I always have trouble remembering, you know, what was the key messages I was supposed to remember for the day. And so I wanted to make it easy and tell you up front what are the key messages I'm hoping you take away today. So the first key message, there are only three. The first key message is that containers are reshaping cloud. So, you know, containers have been around for 10 years, and a lot has happened in that time. But virtual machines have kind of been the main player in cloud for the last 10 years. However, containers seem to be taking off and are becoming very, very popular recently, and it's very possible that containers might reshape the entire cloud landscape as we know it. So it's important that you learn about containerization and what that means for cloud, and keep aware of that trend. The second thing I'd like you to remember is the secret to Docker. Now, you might hear about Docker, you might have heard of it, you might not, you might have played with it, but a lot of people haven't yet played with it, and that's okay. A lot of people wonder, what is Docker, why is it important, and what's its secret sauce? Why is it any different than Solaris Zones or anything else? Well, the secret to Docker is collaboration. That's the thing that makes Docker so special, is the ability to collaborate with other people on containerization. So that's the secret to Docker. I'll tell you that up front, kind of give away the sauce there. The third thing I'd like you to remember is the hard part of Docker. The hard part of doing containers and Docker and creating applications and managing systems with Docker today is multi-server. So these are the three things that I'd like you to take away from this presentation. Containers are reshaping cloud, the secret to Docker is collaboration, and the hard part of Docker is multi-server. So the structure of today's talk is a four-part structure. First, I'll tell you a very brief introduction to who I am, my background. The second thing I'd like to do is talk to you about Docker. What is Docker? What is it made of? Why is it important? Part three is why now? As I mentioned, containers have been around for 10 years. So what's different now than it had been 5 years ago? And now, finally, in part four, we'll explore what the future is. What is the next 5 years of cloud look like, and how is that landscape changing? So these are the four sections of today's talk. And I'll start out with who I am. So as was mentioned already, I am the Chief Innovation Officer at CenturyLink. I've written some books on programming. I founded AppFog. It was a popular platform as a service with over 100,000 developers signing up for it. And I've always been a developer. I've been a developer for about 20 years, and so my background is really heavy in writing code and being in the open source community. And when I was brought into CenturyLink a little over a year ago, they saw what I had done, and they said, Lucas, can you help us not just with AppFog and platform as a service, but help us understand cloud better. Help us strategically get to a place where we can do cloud just as well, if not better, than everyone else in the market. And so, the first thing that I saw missing, the first thing I started working on was an authentic place for developers to engage with CenturyLink and the brand around stuff that's important to developers today. So the first thing I did is I started to create the CenturyLink Innovations Lab. And if you go to CenturyLinkLabs.com, you'll actually find a wealth of information. There's blogs, podcasts, YouTube videos, tutorials, mailing lists, and we're really building a community. And I'd love anybody listening right now to join this community, be a part of it. Tell me what you're interested in learning more about. Tell me what your concerns are, and let's make this a dialogue. This should be the starting point. If you haven't heard of me before, if you haven't heard of the Innovations Lab, if you haven't heard of CenturyLink, let this be the beginning of a journey together. I'd love for you to join the journey, and we can work on difficult problems together and solve problems. When they brought me in for figuring out how to have developer awareness and presence with the community, one of the things I told them is, let's be there as active community members and do the right thing. Let's really put out great information, and that's what we try to do every single week. So that's what I do. What is Docker? This is what we've all been waiting for. This is what this whole conversation is about. If you don't know what Docker is, or if you kind of know what it is, the first thing that you should know about Docker is that it's reshaping the cloud. It is one of the most popular open source projects that has ever emerged. In just the last 15, 16, 17 months, it has gone from nothing to millions of downloads. I think that the numbers here are actually a little out of date. It's kind of hard to keep up with because this slide was 1 or 2 months old. Now it's it's multiple millions, multiple multipliers of every number you see here. It's hard to keep up because people just are so excited about this project. It's taking off and transforming how people think about cloud, how people think about building applications. Cutting-edge organizations are adopting it very, very quickly. eBay uses it, Cloudflare, There's tons of meetups. Pretty much every major metropolitan city internationally has a Docker meetup now. So it's really been a open source project that has transformed how people think about cloud and what people do with cloud. And so the question becomes why? What is so cool about Docker, and why are people so interested in it? Well, the basic idea behind Docker, and one of the most common ways that people think about it, the analogy that they use are shipping containers. So Docker containers are like shipping containers. And before shipping containers, when you were trying to transport cargo, you just throw it on your ship, and who knows what's going to happen to it. You just throw the piano along with your chairs and furniture and hope that they all survive. It was not very easy, and it was not very efficient. And that kind of Wild West of moving cargo is kind of how the world is today, in the analogy that applications right now are tightly coupled with the underlying operating systems that they run on. So trying to separate your application from the underlying operating system and configuration management right now is very difficult. It's kind of everything's mashed together, and there's no way to encapsulate the logic and structure of an application, and that is where Docker steps in. So Docker provides standards. Docker creates containers which are very, very lightweight. And if you haven't tried a Docker container, you can actually do it. You can spin up a Docker container in less than a second. It's in like a microsecond. You have a full encapsulated Linux environment at your fingertips. And that is really, really useful. When you talk about virtual machines, sometimes it can take minutes, tens of minutes sometimes to spin up a virtual machine. And with Linux containers, they're a lot more lightweight. You can put lots and lots of them. There's very little overhead. So if you're looking at virtual machines, you might be taking a 10 to 20% performance hit in a virtual machine rather than a bare metal machine. And just for the virtualization, for Linux containers, there's very, very little overhead. It might be 1% or 2%. And so they're lightweight, they are faster, and what they allow you to do is encapsulate the entire structure of your application within the container itself. So all of its dependencies, all the binaries, whatever configuration is necessary can be encapsulated within the container, which gives you standards. And that way, instead of moving applications blindly or having applications so directly tied to the operating system that they are inextricable from the underlying operating system, makes it unreproducible. It's kind of like throwing cargo onto a ship blindly. Now you actually have containers, and the operations team can manage the containers from the outside, and the development team can manage containers on the inside. So you can start building your website inside of containers and including all the dependencies exactly how you need it, make it completely reproducible. So the code that runs on your development machine runs exactly the same way on your development machine as it does in production. There is no artifacts, there are no dependencies, there's no versions, because all of those things are bundled into your container itself. So the code and all its dependencies are bundled, and so the operations team, all they have to do is say, okay, I just need to run a container. I don't have to know what's in it. And so it creates standards for encapsulating application architecture. So the developer worries about his code, his libraries, his package manager, his apps, and his data. He worries about that inside the container. And the ops guy worries about logging, remote access, monitoring, network configuration, and figuring out how to connect all those containers together. So it separates concerns, which allows the operations team and development team to work in better unity, because now they speak a similar language. They have standards that can be used inside and outside of containers, and it creates the ability to have efficiencies that never existed before. So all of that promise is amazing, but you have to remember that Docker containers are still very young. It's a project that's only been around for about 15 months. And right now there's only about 18,000 containers, at least 18,000 images out there. And so Docker is still early and has a long way to go to catch up to 46 million VMware virtual machines. So it's still a developing technology. I don't want you to go away from here thinking, well, okay, Docker is the end-all, be-all. It's taken over the world. It is still early, and there's still a lot of work to do. There's still a lot to build to make it easier to adopt, to build tooling around. So it's very promising and very quickly being adopted, but there's still a lot of work to be done. So this is one of those things that you should be playing with, you should be thinking about, you should be doing research on, and even in small cases, putting it in production. Just a few months ago, nobody would recommend you put Docker into production because it wasn't even 1.0 yet, but a few months ago it became 1.0, which gives it some stability. And so now you might want to start thinking about doing small systems that would work, at least get your feet wet with Docker and become more familiar with the tooling and how it works. So why now? We'll move on to part 3 of our discussion. Polaris zones have been around for a long time, and BSD jails have been around for a long time. LXC containers have been around, and all of these things have essentially done the same concept. They have taken a lighter weight approach to virtualization, and you might say, okay, so what do you trade off? You might wonder, okay, if you're getting speed and velocity and these systems are faster to use and more agile, what's the trade-off? What are you trading off? Well, one of the major things you're trading off is encapsulation and security. The way that containers get away with being so fast and agile is that they share the same kernel. So every container is sharing the same kernel space. If there is ever a kernel hack, a zero-day exploit, it is theoretically possible for a container to be broken out of. So it's theoretically, now not very practically easy, and people don't have proof of concepts of this very frequently, but it is possible that if there is a kernel exploit that you could break out of these jails. Virtual machines provide more isolation, and these containers provide more agility and velocity. But containers have been around for a long time. Why had they not become more popular? Well, security was one thing, but there's another part entirely that held back their adoption, and that was they were stuck. What do I mean by stuck? Containerization technology was held back because the way they worked was very, very isolating to a specific underlying operating system. Because when you were dealing with Solaris zones, you couldn't move them to a Linux machine. When you were dealing with BSD jails, you couldn't move them to Solaris zones. When you're dealing with LXC, you can't move it to anything else. So all of these container technologies were stuck, and you couldn't share anything. You couldn't share images. You couldn't share containers with anyone. So they were. The idea was you could always use jails and zones to create isolation within a machine very quickly and lightweight, but you couldn't move between machines. You couldn't take a BSD jail that was running on a BSD machine and move it anywhere else. You couldn't even move it from one machine to another machine also running BSD. They were just stuck. They were stuck on the machines that they were started on. So they provided some utility, but the thing that uniquely has taken off and made containers so incredible has been that Docker allows you to collaborate on containers. And the Docker Hub makes that collaboration public. It gives you a centralized hub where you can actually share stuff with anybody in the world. So I can be running Docker on my Mac. You can be running it on your Windows PC. And we could actually, I could commit and create my Dockerized container on my machine. I can Docker push it, and you can Docker pull it, and have an exact copy of that container on your machine running exactly the same as the container running on my machine. So this is the big aha moment for containers, is making them portable and interoperable. Making them things that you can move between systems, making them, creating images, being able to share images, and being able to reproduce images with a known certainty. That way I can develop on my laptop, move it into QA, test it in QA, move it into production. And at the entire time, I have complete certainty that it is the exact same code with the exact same dependencies moving through all of those different ways to run your application. So that is what makes Docker and containers so popular within the last 15 months. And the Docker Hub takes it that one step further, because with Docker Hub, you can actually, instead of just pushing and pulling between me and you, we can now push it and the entire world can see my Docker containers. This is so powerful because now people are starting to build things, build DevOps technologies in public. They're starting to create stuff that is very, very valuable and make it reproducible for everyone. So people are flocking into the Docker Hub. There are thousands and thousands of developers and ops people signing up for the Docker Hub every single day. Every day, thousands of people join. They're contributing Docker images. They're creating private Docker images that they share with their teams. They're committing Docker stuff on their machines and pushing it to the world. And they're iterating on concepts around Docker in a collaborative way. And if you think back, this is not the first time this has happened in technology history recently. If you guys remember the source control systems of the past, we had CSV and or CVS and Subversion and all these earlier version control systems. And you might remember when Git came along and had all this fanfare at the beginning. And when you first heard of Git, you probably rolled your eyes and said, well, what's so special about Git? Git's just another source control management system. Like, why? Like, I'm happy with Subversion. Why would I ever want to switch? And the thing that Git did so well was allow people to collaborate easier. Subversion did an okay job, but the beauty of Git was in the forking and the collaboration. So if Git made collaboration easier for source control, dramatically easier. It was, Subversion and earlier source control systems were all built to help you manage your own code, but they weren't built to have teams of developers, hundreds, thousands of developers working together on a single code base. Whenever you tried to do that in Subversion, that really made things confusing, and it fell apart. Git came in and solved that, and then GitHub came in and made it all public. So now people can collaborate on source control publicly. They can get people involved in contributing to open source in the public. They can store all their private repositories online and have them accessed anywhere. And so GitHub brought light and collaboration to version control. Docker Hub does to DevOps what Git did to development. It fundamentally changes how people collaborate on DevOps technology. It brings to light. It creates reproducible environments, and it lets people collaborate on reproducible environments. That is something that no technology in DevOps has ever done before. We've seen configuration management like Puppet and Chef, which are all fantastic and very good technologies that have a place going forward. But the cookbooks and the recipes, they didn't quite encapsulate everything that you need for the entire state of creating applications using containers. Containers are much more elegant and are lighter weight than managing configuration management systems, and they're a lot friendlier to developers. The operations teams are very happy with Puppet and Chef technologies. Developers don't like them so much. That's one of the big differences between Docker and containers and some of the previous DevOps technologies is Docker is just as exciting to the developer as it is to the operations team. So it's one of those, it's a bridge building technology that is making knowledge more public, more collaborative, and it is very exciting to developers as much as it is to the operations team. So what's the future? Now that you understand where Docker came from, what's its heritage, and why now, why not 5 years ago, what looking forward is the future of Docker? Where are some of the pitfalls? What should you look out for? And how should you think about incorporating Docker in the future? So Docker was really built for single hosts. Even though you can push and pull containers between hosts, the Docker system is very single host minded, and when you're building complex large-scale applications and you need to deploy them to a lot of different servers, not just one, and you need to have various containers, 10, 20, 100, 1,000 containers split up between all these servers. Managing multi-container Docker applications becomes very, very complicated very quickly. And it's not really a big surprise there. Managing any multi-system is complicated and usually requires orchestration. And there's been a whole set of orchestration technologies being built around the Docker ecosystem over the last few months. Some are pretty widely talked about. Kubernetes has come from Google and is an orchestrator of multiple container technologies. Fleet comes from CoreOS, which is a really cool Linux operating system that's built for Docker. Mesos is an Apache project. So there's all sorts of different ways you can orchestrate multi-container, multi-host systems. And all of those are really still emerging technologies and still young technologies. So you're combining Docker, which is already a young technology, with orchestration technologies that are even younger than Docker. So there's a few things about that. One is that you're still very cutting edge, you're bleeding edge, and you've got lots of learning to do for stability and making sure you've got like all your bugs and kinks worked out. But even more fundamentally than that, even before you even try to get started, there's so much more to learn. So just figuring out how to use Docker and push and pull is great, but then once you want to put that into production, if you're on the operations side of things and you need to orchestrate large systems, there's so much to learn. And learning Docker alone has a significant learning curve. And then learning about how to use the technology to do orchestration has another set of learning curves. And it's a wide variety. There's so much to be learned, and there's so many different moving pieces. So you have to learn about etcd and systemd and fleet, and if you could look into console and consulate and configurator and or the Kubernetes project or GearD from Red Hat. There's so many different technologies. Each one has its own learning curve. Each one is as complicated as the other one, and it can be very frustrating to try to keep up with it because it's all, every week it seems like there's a new thing to keep up with. So at CenturyLink, I've been following Docker very closely, and I've been watching and I've been thinking, why isn't there something that makes Docker management easier? Why isn't there something that helps regular people and makes it so that you can, Docker is such a disruptive technology. Why isn't there something that makes that disruptive technology easier to adopt without having to learn everything else involved? So CenturyLink actually has funded me to build a team of people who created a project we call Panamax. And we just launched it yesterday, so this is very, very new. We've been working on it for months, many, many months of creating this. What we wanted to do was not create another orchestration engine. We didn't want to create another Kubernetes. We didn't want to create another Fleet. We didn't want to create another Mesos. We didn't want to add something new that you had to learn. We wanted to instead build a technology that leveraged Fleet or Kubernetes for you, that made it easier to adopt these new technologies that are moving so quickly. So visually, you can see we wanted to create the developer and ops workflow. We didn't want to reproduce the containerization or operating system technologies. We wanted to live at a layer above that. And this isn't platform as a service. This isn't PaaS where you're deploying just simple applications that scale horizontally, just like that. We wanted to create something that you could do complex applications. We wanted to create something with a great user experience where you could drag and drop Linux containers, where it wasn't just cookie cutter templates. You could use anything within the Docker Hub. We wanted to create an application marketplace where you could actually, after creating complex Dockerized applications, you could share them with your friends. We wanted to leverage orchestration tools like the stuff behind CoreOS. So we created Panamax, and it's a really great system, and I'll show you a quick demo of it. So Panamax is an open source project, and it runs the same on your laptop as it does on any cloud environment. It can run on CenturyLink cloud. It can run on Rackspace, Amazon, Google. Any cloud environment can run a Panamax installation. It's an open source piece of software, and we wanted it that way. We wanted to make a system that that people could leverage widely to use for their Docker experiences. And when you install Panamax, this is the screen you see for creating applications. So you can start with something just by searching for it, and it searches the Docker Hub. So if we click on WordPress, this is actually searching the entire Docker Hub for any Docker containers out of those 18,000 that have WordPress on them. So you can see lots and lots of people have been creating WordPress containers, and you can take advantage of them. Instead of having to learn all the commands to run them yourself, you can just use Panamax, press Run Image, and it'll pull it down for you, and it'll start it up and run it for you. So instead of running just an image, we're going to run a template here. And a template is like an image, except it's multiple images. So it's multiple containers. So we'll run this WordPress template. And what happens is we actually are creating a 2-container system right now, and we're stitching those containers together for you. Underneath the covers is a lot of that orchestration technology we just talked about. So this is already running CoreOS. We set CoreOS up for you. We set up systemd files for your containers. We set up etcd registration, and we set up the linking between those containers. So we've done the heavy lifting and encapsulated the knowledge of running multi-container applications with Docker for you in an open source project that you can use anywhere. And remember, I said this is not platform as a service. If this was just platform as a service, the only thing you could do is scale up and add more WordPresses. You can make, add 10 or 100 WordPress containers, and that's what platform as a service is really built to do. But with Panamax, you can say, well, I want to build something more complex than a WordPress application. I want to add Ruby on Rails to my application. And you can do that with one click. You can search the Docker Hub, and when you search the Docker Hub, anything in the Docker Hub can be added to your application. You can start stitching together different technologies one by one. You can add different tiers. So if you want to add a load balancer tier, you can add a load balancer. And if you've ever worked with a platform as a service, you know that you can't choose your load balancer in platform as a service. You can't, you have to use whatever the platform as a service has chosen for you. Here, not only can you can choose from any load balancer that's on the Docker Hub. And every open source load balancer is out there. HAProxy, Nginx, Apache, anything that you want to use can be used with a click of a button in Panamax. So you can leverage everything in the Docker Hub, all the knowledge that people have used to create these great containers, and you can stitch them together into your application. You can imagine building systems that have 100 Hadoop containers, and you build out a 100 Hadoop container system, use Panamax to deploy it, and you can deploy it with one click. So once you've created your complex application and you've stitched together all the Linux containers you want, the most powerful part about Panamax is that you can save that multi-container system as a template. And when you save it as a template, you can then search for it and reproduce the template anywhere that you're running Panamax. So it makes multi-container systems portable and lets you take them across any system, any host, any cloud that can run Docker. So this creates a system for application architectures with Docker and being able to create these systems that are really complex, but be able to package them and distribute them a lot easier, reproduce them a lot easier. So when you save it as a template, it goes into a GitHub repository. So it could either be a private or a public Git repository. If it's public, anybody in the world can then take your template and reproduce it on their Panamax. So you can share it with your friends. It's not just you that can reproduce it. Now your friends can reproduce the applications you build. So if Cloudera builds a Hadoop cluster with Panamax and saves it as a template and shares it with the world, then I can now use Cloudera's Hadoop cluster and reproduce that cluster with one click. If you go in and you search, you can already see that there is the beginnings of a template library being built out. So we've already got Drupal and GitLab and Grafana and MediaWiki, all sorts of technologies that you can reproduce just with one click. And we're going to see this community growing, this ecosystem growing around building out more and more application container systems and sharing them with in a reproducible format using the Panamax tool. So you can try out Panamax right now. You can go to panamax.io and download the source code, put it on your laptop. You can go to CenturyLink Cloud and deploy a Panamax installation. We're going to have a blueprint for Panamax on CenturyLink Cloud very soon, which will make it just super easy to do one click and have a Panamax that you can use to deploy complex containerized applications on CenturyLink Cloud. And you can use, if you don't have CenturyLink Cloud yet, you can get a trial with Agitaire, who's our host for today's webinar. And they've got a great system set up so that it's very easy to try out CenturyLink Cloud, and they'll help you understand, get you started with all of this. And so it's very exciting. I want to go back and review where we started from, and then I'll leave it open for some questions. So let's talk about the things that we wanted to remember. And number one, containers are reshaping cloud. Containers are potentially the next iteration of virtual machines. Virtual machines were kind of cloud 1.0. Containers could be cloud 2.0. We might see containers reshape the entire landscape of cloud, and so it's important to understand what they mean today. Number two, the secret to Docker is collaboration. The Docker Hub, being able to share Docker images and containers with other people is the secret to Docker. And number three, the hard part of Docker is multi-server. There's tooling that's being built to address these problems today, but it's still very early. And there's a lot of work to be done, but we need people to join the community and join the discussion to help us mature the tools and try things out. So if you're interested in learning more, you can contact me on Twitter at CardMagic and reach out to our friends at Agitaire. These guys really get it. They understand these DevOps technologies. So I'd like to open it up for any questions.
Okay, remember on the questions pane, ask your questions, and we do have a couple. So Lucas, one is, in your WordPress demo, does WordPress know about MySQL?
Yes.
Or do you have to configure it? Oh, so it does know. Okay.
So I'll actually show it to you.
Okay.
So when you go in to manage the application, the whole idea with the WordPress system is that these templates are built to be reproducible, self-aware applications where you don't have to go in and have to do a lot of the heavy lifting. We wanted to do the heavy lifting for you. So there's two views that you can have on any application with Panamax. There's the category view where you see the different tiers, but there's a linking view. And in the linking view, you can see that the WordPress is actually linked to the database. And this is where you can actually, the WordPress container already knows that the database exists and it already knows how to talk to it. So you can go in, and we created this Nginx container, but we haven't done any linking of it. So because this wasn't a container or a template that had a load balancer in it to start with, the load balancer wasn't linked to the WordPress container yet, but that's something we can easily fix. You can go into the Nginx container and you can add a link to that WordPress container, and you can add some port bindings so that inside the container, Nginx is running on port 80, but outside the container I want to access it on port 777. So I can make those changes within Panamax, which will distribute the changes into the running application. But templates are pre-built to understand the topology of the application so that you don't have to stitch together the database.
Very good. And Panamax, is it written in Go?
It's written in Ruby.
Oh, in Ruby. Excellent. One question, there's an individual out here that's not a U.S. citizen. They're in the U.S. Can they participate in the Panamax contest?
They can participate, but they can't win any prizes. We're looking into the legal aspects, and it was going to take too much effort. We didn't have enough time to do the registration internationally, but we do plan, if this is a success, to do more international contests.
Great. And remember, just if you have any questions, put them in the questions pane. So I want to come back to security. Regarding a kernel hack, when you spin up a container, is it isolated? Is it locked down? Are there any holes when you fire one up under Docker?
Yeah, it is isolated, and again, the biggest hole is that it shares the same kernel. So
yeah.
So the only way to get through it is through the kernel. But usually, if you trust that the kernel is secure, then that's okay. You can do more than just hoping that the kernel is secure by incorporating SE Linux rules into your host environment and into your containers, and that is one way to mitigate the risk that the kernel exploits might present themselves with. But other than that, each container does give you root access to that container, and they're independent containers. You can run on a host Docker machine. You can run different underlying operating systems for your Linux. So one container might be RHEL, and one could be Cent, and one could be Ubuntu. So it doesn't, you can have a lot of flexibility of what runs inside your container. And they are definitely isolated. They do share the kernel.
Right. Well, so what about in terms of the resource demand against the host? What happens if you have a bad actor? How do you manage that?
Yeah. So those are some good questions. I think there's technology being built to manage that kind of stuff. That's its own webinar in itself.
Maybe that's part 2. Any additional questions? Let's see here. How about when you deploy when you're deploying apps across multiple containers, what are the challenges, and is this where Panamax can help out?
Yes, this is where Panamax can help. The challenges are that learning about how all of the orchestration systems work it takes a lot of time to understand those things, and you will want to understand them eventually, but Panamax can do the setup process for you and let you get started without having to understand how all the orchestration works underneath the covers.
Got it. Okay, let me bring my questions pane up here again because there's 2 more questions. Okay, even with Panamax, if you run CoreOS and Docker containers on AWS, you can use auto-scaling to expand, reduce your CoreOS clusters, but the Docker scaling will have to be manually scripted. I think that's more a statement, but a question about how do you handle the Docker container?
How do you handle? Can I hear that question in a different way? Could you ask it in a different way?
Yeah. So I think what they're trying to say is even when you're running the CoreOS and Docker container on AWS, how do you handle auto scaling? Do you have to go and manually script Docker to scale?
Yeah. Right now there aren't good auto scaling technologies. Again, the whole Docker ecosystem is so young and moving so quickly. I think that right now the answer is you do have to build it on your own. My suggestion is join the Panamax project and make auto-scaling a feature of Panamax. Help us, do a pull request and help us add that functionality so that it's reproducible and not just one-off. We'll get to it eventually, but we really need community engagement and support to do things really quickly.
Great. I've got one more question. I'll flip over to our contact information for those that might be interested in the trial. So we want to talk a little bit about hiring. I know we've got one individual down in San Francisco looking for an opportunity. What's going on at CenturyLink?
Yeah, CenturyLink is aggressively hiring. We're looking for people to get cloud, and we've got the team up in Seattle that's working on CenturyLink Cloud. We've got a team in Portland working on the labs and this Docker-related stuff. And so we are actively recruiting, and if you're interested, just reach out to me, and I'll forward your information to the right people. Excellent.
Well, I did put our contact information up for Edge-Tier Technologies. Myself, Jim Palmieri, and Toddy Miladinoff. We run the company. We are master partners with CenturyLink. If you're interested in a trial, we'd be happy to help you get on a trial, and we can talk to you about the platform. If there are no other questions, I think anything from you, Lucas, that you want to add?
I appreciate you guys' time and spending some time.
Wait a minute. I've got a couple more questions coming in. Hang on one second. Okay. What about Windows applications?
Yeah, that's a great question. Windows applications are not currently supported under Docker, but they will be. There's work underway by multiple parties to do native Windows apps, but again, early technology, and there's still those edge cases that need to be worked out.
Got it. And does Panamax help with monitoring of your Docker container?
It does, yes. We have built in some basic monitoring. We're going to be adding historical monitoring that will automatically keep track of the entire state of your system and give you pretty graphs that show you the system over time. But we already built in a container that's from Google that is able to keep track of the state of your application, and we bubble that information up for you, which is a really nice thing, because when you're running Docker without Panamax, it can be sometimes hard to see what the state of your entire application is.
Great. Any additional questions? No? And then how about, in terms of happening in the industry and thought leaders, who are the guys out there to follow?
There's a lot of interesting work going on. I've been doing a podcast on the CenturyLinkLabs.com website, and the podcast, I've been trying to interview as many of the thought leaders as possible. One of my favorites recently was with Jeff Lindsay, who is on the Docker Foundation, who comes up, he's one of the thought leaders that invents a lot of technology that we use in the Docker ecosystem every day. So Jeff Lindsay was a really, really great interview. I talked to the guys who created Flynn, Jonathan Rudenberg, who's super smart. He came out of Shopify. Yeah, but if you subscribe to the podcast, you will learn the people that you should be paying attention to.
Great. One more. So in terms of, I know the way Docker isolates to the hardware, but there's a lot of really interesting things going on with hyper-threading and technology, hardware technology. Is there any kind of balance in terms of using these solutions on a platform when you're configuring the platform, the infrastructure?
Can you say the question in a different way?
So in terms of deploying the Docker's containers into the infrastructure, whether it's like Intel or there's a lot of hyper-threading technologies that are being used, and they're evolving. Is there any pros and cons in deploying against one versus another? And is there anything that's advantaged?
I know that there are people working actively on advantaging it. I don't know if anything is mature enough at this point.
Okay.
I don't know if there's a leader. I haven't seen one yet, but I do know that there is a lot of active involvement in working on processor-based enhancements.
Great. Well, just a reminder too, we've recorded the session. We'll be posting it out on the site. If you have questions, additional questions, feel free to either add them to the site or send us an email. If you're interested in a trial, it's a really cool platform to use. It's a lot of fun to use it. So we can spin you up on one. And Lucas, thank you very much for doing this for us.
Yeah, thank you for your time.
Okay, great. Thank you. Thank you all for attending.